check. We are live.
Yeah.
Yes.
Yeah. So I mean, it's a neat way of doing it.
Okie dokie.
Is that too? You can still
Yeah, I think we're gonna see. Welcome everybody. Today we have unlucky number, class number 13. First of all, well, Ollie just popped out, but pretend Ollie is here. I'll repeat that for his benefit when he's back. I don't know how many of you checked, but we have now a new website.
Yeah.
Yeah, it's a very nice website. It looks and works much better, and all this is done thanks to this gentleman at this walking. So thank you very much, Ollie, for this. You know, it took a professional to take care of the website, which we really appreciate.
What software did you use? Did you just like use WordPress, or was it like?
Today we'll be learning more about classes, so be ready with that. I decided to give you a little bit of update. We have now over 290 subscribers on YouTube. And we have so far over 2,500 views on our class. We're a small meetup, but you know, by the look of it, we're getting the quite a lot of hits. So far, we had 4,320 minutes watched online of our classes. So we're getting some traction.
Do you want to get subscribers?
Yeah, we have over 290 subscribers.
Okay. So how much? When do you start making money?
No, it's not for money.
No, but you should be able to.
Well, I think we would have to go to hundreds of thousands. Yeah, probably. Then, unless we're targeting like beer.
You have internet sensation.
Probably like the 290 would translate something like 2.9p. Yeah. For all the newcomers, our classes are weekly. You can watch us, or you can join us on site. They are free of charge. You can watch us online. Please do bring your laptop with us. If you need Sea Lion ID, just email me and I'll send you a copy. And obviously follow us on website. Our website is cpplondonuni.com. Follow me on Twitter for the latest updates. My nick is xxvms. And obviously please do RSVP. You've done an amazing job for this class. Or maybe they had spec, don't know. But I'm glad we are in a big room, not in a cupboard, shoe cupboard, yes, which is obviously very nice. So the next classes is 31st of July and at 7th of August. Oh my goodness, it's August already. Yeah. So, you know, go to Skills Matters website and RSVP on their websites. Just to repeat, if we are in Skills Matters, the important part is to RSVP on their website. Why? Because they see people coming and they'll give us a bigger room. If we are in different place, let's say Mimecast, King, or anywhere else, when the site does not provide RSVP like Skills Matter do on our website, so we can provide the list of the names for the badges and so on. I have a bunch of new licenses, so if you're missing a license and you want Sea Lion, just email me. In the subject line, put Sea Lion license, so I can fairly easily find the email. And inside the body of the email, just put your name, email address, your name, surname, and email address. So then I can quickly copy and paste and send you the license. Then there is a list. Put your name in. Put the tick on next to your name. If it's mistake, correct the name. If it's not your name there, just add your by pencil, and I will add this to the list for the next time. After our class, we're going to pub to pay respect to these two chaps. I encourage everybody to go in. That's the cheapest education you can have in London. So buy these guys a beer, yes, or something warm to eat. And thanks to Tristan for leading the class, and I'm kind of quiet, and you have the expert.
Sorry, what's your email address?
Tom at
cpplondonuni.com.
Yes, okay. Ollie, you can tell because I can't remember them.
It's Tom at cpplondonuni.com. Our website. Because now we've got a new website and we've got email addresses. Awesome. Okay, welcome everybody. So is there anybody who's here for the first time? Yes, hello, welcome. Hi. You've dropped in at session 13. Quite late in the game. But have you done any C++ before? Or? Okay, so we're going to be talking about class constructors today, which is, Python has a similar sort of idea with different syntax, but so hopefully you'll be able to follow. But when we do the exercises, we can give you a hand. Since it's your first session, you won't have seen this slide that I always put up first, but everybody else has. We do have this Slack channel that we ask everybody to join, so they can chat to us in the 6 days a week we're not here, and discuss anything you want to discuss. So yes, you can go to that URL and just pop your email address in, and it will send you an invitation to join. It's a very exclusive club. Anybody who goes to the website can join. We have a textbook that we hardly use, but we do occasionally delve into it for exercises and things. So it's this weighty thing by Bjarne Stroustrup, who's the guy who invented C++. So he hopefully knows what he's talking about. So if you'd like to get yourself a copy of that, it's on Amazon or all good bookshops, as they like to say on the BBC. So please do go ahead and do that. Right, that's the standard preliminaries out of the way. Today, what are we doing? We're going to have a little bit of revision on what we did last week about constructors, and we're going to talk about explicit constructors, what the explicit keyword does. We're going to talk about member initializer lists, what they are, how to use them, why you want to use them, and then we're going to talk about the remaining special member functions, or well, most of them. Destructors, copy constructors, and copy assignment operators. I did originally say we were going to start to talk about member access today, public, private, protected, but feedback I got from last week is people liked having more exercises, so got rid of the extra material. Give you a bit longer to do exercises today. So, although all the slides are there, so if we do get to the end and we've still got time, I can charge on with that. So if you want to burn through the exercises really quickly, it's up to you guys, really. Okay, constructors. So who was here last week? Most of you, but not everybody. Okay. So C++ structs and classes, which, as we've discussed, are exactly the same thing, has this notion of a special kind of function called a constructor. And a constructor runs when we create a new instance of an object. Sound familiar? Yeah? It's all coming back to you. I know a week's a long time, right? And the constructor's job is to make your new instance of the class ready for use. So the technical terminology is to establish the class's invariant. But, basically means setting up your member variables, setting up your base classes. When we go on to talk about base classes, we haven't discussed those yet. But that's the job of a constructor. So that's what a constructor does. How do we write one? It's written using the same syntax as normal member functions, except that a constructor has no return type, and we can't make it const, and it has the same name as its parent containing class. As with all member functions, or with all functions, in fact, we can have multiple overloads. That is, multiple functions with the same name, but having different argument lists. And this is a very normal thing to do with constructors. For a class or a struct to have many different constructors, several different constructors, taking different arguments. a normal and usual thing to do, and we refer to these as overloaded constructors. Is this all working on the stream, by the way? Coming out, awesome. It's a special kind of constructor, a kind of constructor that takes no arguments. So it's just an empty pair of brackets, usually. There are a couple of different ways you can write it, but a constructor which can be called with no arguments. It's called a default constructor. And a default constructor is one of what's called the special member functions. And what makes them special is that in certain circumstances, the compiler will generate a default constructor for you. And or will generate the special member functions. That's what makes them special. But in particular with a default constructor, if you don't write any other constructors yourself, the compiler will give you a default constructor. And I haven't mentioned it here, but what the default constructor does is it just default constructs all of your base classes, if you have any, and default constructs all of your member variables. If your member variables don't have default constructors, then you won't get a default constructor for your class. But this only applies, the automatic generation of the default constructor only applies if we don't write any other constructors ourselves. If we do write other constructors, but we still want the compiler-generated default, we can specifically request it by writing the constructor declaration and then putting equals default after it. So that's a way, you can do this with all the special members, as we'll see later in the class. This is the way to say to the compiler, I want you to generate this for me, please. But we can also do the opposite. If the compiler would otherwise generate a default constructor, but we don't want it to, we can use this syntax equals delete. So instead of equals default, we say equals delete.
When would you actually use delete?
For a default constructor, rarely, because as we say, if you write any other constructors, you don't get a default constructor anyway. So you can delete the default constructor. You normally only use it for in very special circumstances. So not very common for a default constructor. It's a lot more common when we get on in a few slides talking about copy constructors. It's quite common to delete the copy constructor so that you have a type that cannot be copied. And in several weeks' time, we'll start talking about move semantics. We'll talk about move-only types, so types that can't be copied but can be moved.
Where does that equals delete go? Is it after the constructor?
So you write the constructor declaration, and then you write equals delete, and then a semicolon. So you write that in your class body, in your struct body. It's worth, well, perhaps it's worth noting. You can actually, equals default is only available for the special members. But this equals delete, you can actually mark any function whatsoever as deleted. And then if you try and call that function, you will get an error message saying, you can't call this has been deleted. Which sounds like a very strange thing to do, but it can actually be quite useful in certain circumstances. Because let's say you have a function that takes a double as an argument. No, the other way around. Let's say you have a function that takes an int as an argument, say. Now, the way the implicit conversions work in C++, if someone tries to call that function with a double, that double is just going to be truncated, which is not necessarily an obvious thing, might be surprising. So what you might do is you might write an overload for that function, takes a double, and mark that as deleted. So then if someone tries to call your function with a double, they're going to get an error message, and they're going to have to decide how to convert this double to an int. Maybe they want truncation, but maybe they want rounding, maybe they want something else. So that would be a reason to delete something that isn't a constructor. Anyway, back to constructors. Just to give you an example of what I've just been saying. Literal struct called example. So we'll start off with an explicitly defaulted default constructor. how would I write an explicitly defaulted default constructor for struct example? Give me an example of an explicit. Yeah, I'm not going to say it again.
Equals default.
It's example, parentheses, equal, as in curly brackets.
Almost. So it's example and then an empty set of brackets. So this is a default constructor. Sorry, lose my voice. So this is a default constructor, for example, and then we're explicitly defaulting. We are saying, please can you generate this for us? So now we'll just have this is an ordinary constructor, takes 2 arguments, in this case an int and a float. Bog standard, normal constructor, nothing really special about it. And then finally, just to complete the set, we've got a constructor that takes just an int, and we mark this as deleted. Does all that sound very familiar to the people who were here last week?
Yes.
Yeah? Nice and easy. Excellent.
So sorry, the equals, just to clear up, the equals default example, it just puts I and F to null, yeah, or null, 0.
Well, we don't actually have any members for our struct here, right? So struct example doesn't have any member variables.
Oh, okay.
But if it did, if it had, like, so let's say a standard string member, then this constructor would default construct the string. The default constructed string is just an empty string.
Even if it's a number?
You saw through my cunning ruse. What actually happens with ints and floats is a bit confusing because if you don't give them an explicit initializer, so you know when you write a member variable, you can say int I equals 0. If you don't give them an explicit initializer in the class like that, then your default constructor is actually going to leave them in an indeterminate state. It's going to give them a random value, effectively. So it's always a good idea, especially when we're using built-in types like ints and floats, to give them an explicit default value in your class definition.
Actually, I think we tried last week, you and I, and I think if you leave them not defined, you're going to get a combination.
So what happened last week, that was because we were using C++ 11, so in C++ 14 mode, and even then, it's to do with aggregates that I don't really want to get into now because we'll delve far too deeply into another rabbit hole. It'll just be a bit confusing. Yes, so now that you're all familiar with that, hopefully a rather familiar exercise for you, because you all had it, well, not everybody was here last week. I think we had a go at this. This is the same thing you did at the end of the last session, so if you've still got your code, you can pretty much just copy and paste it. For those people who did do this last week, I've added a new question to the end, just something to occupy your time. It's not actually required for things we're going to do today, but it might help you out for the homework assignment later. So this is an optional extra question. If you go to that URL, which is, can you all read that?
It's in Slack and on YouTube.
Excellent. This is also in the README file for that repository, so don't worry.
I recommend signing into github.com and classroom.github.com before you access the link.
Yes, this classroom thing didn't work very well last week, but I think that was just a GitHub hiccup. So hopefully it'll work okay this week. So if I give you sort of 10, 15 minutes for that, does that sound reasonable? Yes, Tristan, that sounds great. Okay, excellent.
How many slides in are you?
9.
9 slides.
Yeah,
So you've
but
got
3 or 4 of those are introduction.
9 slides.
14, 12 seconds.
We are performing brain communication. So all the thoughts should be getting to you.
Telepathic, you mean?
Yes, telepathic.
Huh?
This class is very quiet because they send
Oh, I
the
see, I see.
telepathic way,
Yeah.
the responses.
Get the countdown music going.
Did it.
You do this last week?
You did do this last week. So I was anticipating we might have people here who weren't here last week, and today's exercises continue on from that. So I thought it'd be a good bit of revision anyway to get you to do these things. So yeah. Can you actually URL and make sure it's working?
Yeah, it's working.
Okay, cool.
We had a question from Victor actually about the default constructors. But as a point as well, he was saying you do that. That's a user-defined default constructor. I mean, strictly speaking, that's going to be pretty much functioning equivalent to defaulting. It's still not actually considered default. This is default.
It's not a defaulted default
It's still
constructor.
user-defined.
It's not getting to use declared and user-defined constructors. So. The fact that was surprising to everybody on the panel is worrying.
There was that good presentation. Initialization is broken. Something is broken. It's pointing out multiple different ways to construct in different ways that will actually construct the fields if you do it in a particular way.
Yeah. I've got an example of that. I think it's 20 different ways.
I think the worst one realistically is that you can have an aggregate of private fields and just initialize them anyway.
What do you mean?
You can have a class that's purely an aggregate.
Yeah.
It's members of private. Doesn't declare anything else.
Members
Still-
of private, it's not an aggregate. All public members.
Sorry. Wrong way around. Yeah. If you declare them members of public, but the default constructor is private.
Yeah.
Still initialize it anyway.
Yeah.
You won't have to just construct it.
Well, as long as the default constructor is not user-defined, it's user-declared.
If you delete it, but it's
Yes. It's broken.
Which is like
Yeah,
the
it's right.
square root.
If anyone needs any help, by the way, feel free to.
What's the algorithm? Or is it
No, it's the heading on the C.
CMath?
So yes, in the README, if you haven't already seen it, the instructions are a little bit more detailed than I've got on the slide. Sorry?
I've got a good one. This guy worked out if you're talking about you needed to do like a efficient string match, right? Using set.
Yeah.
Stuff this is fine. And takes it on the set, iterates over it.
In order to do what was to
Find a match.
Yeah, I've got a.
Yeah.
It's not specific. Trying to find it where are we? Just doing the line thing like I was looking at putting an operator into the line.
Okay.
But I can make this one work with it just passed as one operator, one argument like that. But this one, it says this must take a 0 or one argument. But
Yeah.
if I define that there and that there.
Okay, so if you remember, there are you can write your operators as
Got my name
either
just
members or non-members.
Yeah.
Yeah. So operator plus takes two arguments, a left and a right. So if you write it as a member function, then the left-hand side is already defined for us. That's the one we're operating on.
Oh, okay.
But if
So
you write it as a non-member,
you need to pass. Yes,
The left
I
and the right
remember we
for it.
discussed that.
Yeah,
Something. Oh yeah, sorry, that just.
that's all right. That's why we do the revisions.
Yeah, no, that's good. That's good.
Yeah, that's what I initially got.
Right. So I need to take that out.
That's okay. So, did you go to that? Have you got a game?
I like that. Yeah. But it wouldn't hurt to individually.
Because I didn't look So, you can type that.
Yeah. I'm just doing something else. So. Yeah. That's all.
Is that V underscore P or V underscore underscore P?
It's a single it's a dash. Between the V and the P is an underscore. But if you go to the Slack,
Is there an yes? Sorry, so there's an underscore between. Because it's not working.
That's
It is
because
because it's like underscore. No.
it's one underscore.
Sorry, yeah, my slides are
Classroom, you misspelled classroom.
Oh. There you go.
Yeah, I know.
I guess before we start, do you have any? Do you have like a sequence? Okay, well that's C lines we talked about. Well, C lines like you can sort of. So now we've accepted that. Let's go and install. So go to Ollie, is it like getting started on the website now? Well, we're not yet, so C line. I can go back to the three. Okay, so go to github.com/cpp. And then if you just, let's just search your particulars. Just type the word course. Course materials 2015. Perfect. And then week, I think it was week 3. Just looking at the yeah, that's what I was saying. So if you skip, I'll share that. It's got instructions for Windows, Mac.
Key information. Git cheat sheet. Okay, I'll pop it.
Space between selectors. Very long time.
Oh, wow.
Oh, yeah, I remember. Sorry, yeah, my name was it's dash dash two dash dash. So if you just press up. Yeah. One question. What's always against me? The extra brackets around last week.
So that's
Type
probably
of
that's
initializer
what
when
you're
you're
instructed.
It's giving literally on the way to function like macro application and it's like
Yeah, it's just a macro silliness.
Yeah, that's like-
No.
like 1 minute.
Well, it's a macro.
10 minutes later, it's still saying 10 minutes later. Rather than hovering over your shoulder, so the so that's there are two parts. There's compiler and constructor. We use the IDE. So the next slide and the next slide after that, talks you through installing CLI. Basically, go to the website, click download. So for CLI to get like a month free, and then if you can come to the classes, you can get stages. So yeah, if you have any
For some reason, it just messes up the free process.
happy now.
Yeah, sometimes. Okay. Yeah, use a brace initializer list.
Excuse me.
Yeah.
I'm doing something. Okay. So we're on. So that's my length. And that's my, whatever it is called, line. Here. I can't seem to call it.
There's a class points and how
Yeah, but you've added it to the line function, right?
Yeah.
Where you're calling it on an instance point.
So it's like you to create a line and then call your length function of the line.
Yeah, so that's a D.
D is a line, okay. So if you do D dot length, okay, if you hover over that, what's it say? No, you need to.
Sorry,
So
that was a grasp.
Yeah, if you hover over it, what does C line say? So if your argument's expected one, okay, let's go and have a look at the definition of that function.
Which is 2 points. S
Yeah,
T.
no, I mean the
length function. Why does it take it from? No, that's a constructor, sorry. The length function. Where did you define length? There's one that takes a reference to a line. Why does it just
Does it?
use itself? It's not with this.
So I've got to change that.
It's the idea is it operates on itself, right? So
Okay.
just take that. Just the point of the length thing is it's meant to operate on this, right?
Yes. Yeah. So length should take no arguments because it's a member function, so it operates on an instance of the class.
Itself.
So it's okay.
It doesn't take anything. It just operate on this.
Do you need to
don't
specify
you don't
this?
need anything there.
No, you don't.
Take no. So your function definition.
No, so it's not like Python where you have to say self
Successful.
as the first argument. That's implicit in C++.
Now into the code. So this one.
Yeah.
So the people who were here last week, have people written their
Either
length
do this
functions?
arrow
Do
length,
this.
I'm still starting. I'm trying to just
or
look
you
up the
just get we can just do X.
Oh, okay.
X is a
trying to
bit,
figure
right?
out how to actually make
X
that
lives
into
inside this class.
Yeah, that's why I said. That's why I said it. It's. I said in the README it's a bit harder because I didn't
Struck.
tell you about
Very instructive.
exactly how to do it.
So
yeah, because I guess the order of operations and all this.
So I
Oh,
have
you got
points.
star.
Um,
Okay, yeah, you're good then.
No, it shouldn't make too much of a difference.
Yeah, you don't need to. You could have this if you want.
So you're gonna go over
Yeah,
that.
so that's what I was trying to do.
Um,
so if you put in just
yes.
S.
Yeah.
Because I have no clue.
I might ask people to come and
Sorry.
load up.
And now, wasn't the lesson?
This is a line, pointing to a line.
Well, we rapidly covered in
So I don't
the
need
first 5 minutes of what we did in 2 hours last week.
Get rid of that S dot.
You should be an expert.
Yeah.
Start. Compiler figures out that you're
So
talking about
if you had to go
start.
Oh, I see. I just right.
I'm actually a bit confused about what it means to add constructor.
Okay, so
Like I know I can understand it in the terms of like Python init, I'm just going to
yes.
but I'm just trying to wrap up how would you even
No, start X.
Okay, no problem.
X
Let's,
squared
Start
plus
at
Y
X.
squared.
Yeah, start at X.
Alright, so
Minus
first of all,
operate pressure should be the multiple.
just put a couple of blank lines at the top of the line.
but it's the same thing.
Inside
it's like,
definition of the lines.
so it's got to be, you've got to remove the,
So,
they're both the same now.
What we want to do is we
It's
want
got
to
to be right,
make
isn't it?
a constructor. So it's like a special kind of
You've
so
got,
it's
line have an
you've got a line,
exit,
it always
line
has
an
the same
exit
name
line.
as the
Dot
class. So
style,
it's
storage
right,
line.
line, and then open brackets, and then
No,
inside
line
there
has
we
a
want
point
to
start, exit
You're
line.
starting in.
So you
So
start
it has a,
with
it has a
both
two
start and
X's
end have
and
type
two
points.
Ys.
you start name.
Yep.
Those
And then just give it something arbitrary.
No, so you want
Okay, so rather than,
you want to
okay,
you want people to give you that
right, so it should be
that value,
start
so you don't give it a default.
dot x minus.
And then so that's start, and then the same again for end. Awesome, right?
Start.
So put a
Start.
semicolon at the end,
Yeah.
and that's the declaration of your.
Why is it?
Well, I don't know why it's red. If you hover
Is it-
over it, what does it say?
Start end.
Is it because what's it called? Like I haven't imported it correctly?
No, if you go to line.app, just click on that dot. Right, that's
Okay.
very strange.
I think last time the way I imported it, you said it was wrong. I just went up here and then I found the folder import project. Is that
No, this
No, this is fine.
this should be all.
Go to the point.hpp.
Yes, it's there.
Double click it. Construct point. I'll try compiling it. So it's just easy. So I might have syntax error in the header that might be screwing up. You might have syntax error in point.hpp.
No, but I didn't touch this one.
No,
You didn't touch it.
I didn't touch this one. So
Go
it
to-
must be
Go
line.
to line.hpp. Go to line.hpp line 14.
This is the one I did. Maybe it's like
is that? I can't see. Is that curly brace?
it's a curly brace.
Oh, it should be around.
no,
It needs to be in parentheses. Yeah.
And the other same again. Sorry, I couldn't. It's hard to see.
Still. But then here you're declaring it with a curly brace.
Yeah. So when we actually construct an instance,
It's okay to use curly
you
brace.
can use a curly brace. Yeah. But again, this is the bit I wrote. So this, I'm a bit worried. This is.
Well, nobody else is.
Yeah.
What's the magic trick?
I don't know. Do it before class.
See how it's working. That's better. Okay. So now we've written the declaration of a constructor, but we haven't actually written the definition. So what we'll do is we'll copy and paste that. So go over to line CDB. Paste that in. So what I'm trying to do is put curly braces in.
So in line.
So just after no, just after the end there, just put an open curly close. That's the one. So just this bit out here.
Feels like we have done something similar last week, but it's not completely the same.
It's not completely the same. So what we need to do is, because this is a member function, so we need to tell the compiler that this function called line
I think it actually wraps LVD.
belongs
But
It's
yeah,
just
class
out.
line. So to do that, put this and now see all the red displays.
tools getting
So now this is now the definition of our constructor. So what we have to do, I say, Right,
just
good
step
sign.
in the code.
So our
Actually, I
you
pretty much always get.
so we have member member variables here,
If
start
something's wrong,
and
it's out of sanitizer.
and here
So I
we're
just
getting
got
passed two values.
Oh, so you
Also,
can
you did that
also
one.
called start and end. So yeah, we can either use this, but an easier way to do it is just to give these slightly different names. Just give them put an underscore in, just so they don't have the same names. Because otherwise it gets a bit confusing between which are your member variables and which are the arguments. Just got. So let's same over here. Now, the body of our constructor, say start, which is our member variable, equals the start point we've just been given. And now the same for end.
Then we can use them.
Yeah.
As
And now we can test this constructor out. So if we go to main, see there's this something down here. It's a function called test line. It's nearly empty. Isn't it? So in here,
we had our first one, which is line
yeah,
0, 0.
yeah, sure. Oh, right. Let's think. We need to give it 2 points. So yeah, just create 2 points called P1 and P2. Let's say. Yep. One, two, and three. Semicolons on the
It looks like one.
and then just create a line.
Would be quite impressive.
Okay. Except you need to create a variable. So you're
Yeah, on it. Or
you
you
can say
on it.
const line L, call it whatever you like. Awesome. And now we can just compile that and make sure it runs correctly. Yeah, so it's compiling correctly, but let's just make sure that it's doing the right thing. So I added this print function to your lines. So that's the one. Yeah, and then semicolon into that. Play. See, I have to not remember standard. Oh, so you have to go to the top. Just import hashing items. Okay. Play. Should hopefully bring line from 1, 2 to 3, 4. Awesome.
That's how you initialize or constructor.
So we've now done bullet point 2 of that. So we've added a constructor which takes 2 points, and we've used that to initialize our start.
And we've done number 3, right?
No, we haven't. So we don't have a default constructor. So the next task is to write a default constructor.
That would just be.
So it's a constructor that takes no arguments. So here we've got a constructor that takes 2 arguments.
So we just delete this and then. Like,
Well, no, I want you. So rather than deleting that, I want you to add a second constructor.
So like something like line is equal to default.
Almost, you need to do line and then an empty set of brackets. That's the one. Yep. So that's declared a default constructor. That's fine.
And then I go here
Yeah.
and then I delete.
Right, so we still want this. We don't want to delete anything. What we want to do is to add a definition of the new constructor. So that's the definition of the first constructor we wrote. So we need to add a second definition. Yep.
And then here you do nothing.
And then we need to open and close braces. Well, we want to set both start and end to 0, 0. Is that going to work? No, not quite. So okay, so start is a point. Right. So no. So we've already got a member variable called start. Right. And what we want to so here our member variable called start, we're setting it equal to this other point that we can give. So what we want to do here is we haven't been given a point, but we want to set it as equal to a new point. Okay, so this is saying our member variable start, make it equal to a point 0, 0. Okay, same thing with same.
So this insert actually do anything I guess it only does something when it fails.
Exactly that.
It doesn't say that it will do this, it does that.
No, it's a very blunt instrument. So we will go into how to use one of the very popular test frameworks called Catch. But we haven't quite got there yet, so we're just using this very blunt instrument. Okay, so we've now, that's a test for our 2-argument constructor. Can we write a quick little test for our to try constructing a line, the default constructor line.
So without anything, right? Because it's like a default version, so it's absolutely. But
Does it say that?
Ollie,
Yes. We already got variable.
I know it's not quite on this.
Okay. Yeah, just
Trying to
overload.
I did
So
a
if you
line,
variable, say
a line
you
operate.
declare this thing here, never use it. So you can get rid of that by just printing
Yeah, yeah.
L2 as well, like
No.
we did above.
It's a free function.
It's a free function, but in this member function, here,
So it's variables and stuff like that.
overloaded with
Is
this single one here.
It's in a header called
Yes,
C.
that will be.
So, but when I try and call it on here,
I will be with you
Yeah.
just for a moment.
I want the member. If I remove the external function,
So now, hopefully, if we build this,
because it's calling the member
I
function,
think it's like
line from 0, 0 to 0, 0, which isn't really a line at all.
so do I need
try
to
and-
That's
try and-
exactly what I asked you to do. So,
That seems to work.
that's awesome.
what about delete? That's the same thing.
No.
It's not different. But that's not really part of the
Question which I
Yes.
So if you look in the README, I'll give you a little more details about this one. So, as a folder, so we've done that. We've done that one.
Well, no, it's
Done that
actually,
one?
it's,
I
no,
think
it's
it's,
used, it's actually,
Experiment with marking constructors equals to default or equals to delete. So you'll need to comment out the definitions when you do this.
just
So
returning.
here I
I'm
comment
not
out
doing the
these.
math.
No,
sorry, I
So
comment out
it's returning
these here.
Yeah,
That's right.
So the line
That's equals to
And
default.
then in your line
Referring that
HTTP,
the free
right,
function. Okay, so way around.
equals default, just before the
You
semicolon.
don't need to have
So, yeah, in there. That's the one.
But so,
Yep.
And the other one
that's
just delete.
what I think I mean.
Oh, well, you can just experiment. It's just experiment with it. Just
So in
to,
there,
it's just to, so you can have a look and see what the error messages are. See how it
I
works.
guess I
Thank
never
you very
do it,
much.
do that was the thing.
Right.
So what I wanted to do was,
I mean,
is either provide two arguments, if I provide two arguments,
It just tell me something.
it should go to that one.
Hold on, pause a second.
But it doesn't work like that, does
Show me
it?
the member function.
That's what I was trying to.
Show me the member one.
Yeah.
Point H.
Returning double from a function, returning int.
That's
So
fine. Take that
that's a single one,
That's fine. That's correct.
Because
you
when
put
I-
it on yourself.
Okay, so if you think
but in
about
here,
it, even if your points
Is
have
that-
integer coordinates,
Pile. I don't know why it's saying that.
diagonal
If it was a
would
true
still
error,
have a
pile.
no, it don't.
non-integer length.
So that was what I thought it was
Okay, so the
working,
function
it's
square
like
root
red line
returns
there.
to you double position floating point.
Pile.
Okay, so that's something
Yeah,
to.
that's the definition.
Oh, okay.
What you're
It's
doing
a little icon.
is saying, okay, take the result of that,
Yeah. I should see line being.
and match it to the truncated into
Okay.
I mean,
So
the thing
part
is
of
that
just
really
warning you
you don't
throwing
don't
information.
define those.
So really, you don't
You-
what
you're
you're
making
making, you don't
construct
length function return that. You want to return
Or you, if somebody else wrote
a couple more of those would be fine. Probably
would
wouldn't.
we have a question? Sorry.
Right. Okay. Because the only reason I took it out was because it didn't work, as Tristan said, with two arguments in the main function.
You don't need to if you've got yourself and the other one.
Yeah. Yeah.
That's the point. Well, we're getting on.
You're looking cross there.
Approaching a half hour.
No.
So again, this one.
Did you experiment with the problem last week?
Yeah. I've done that last time. Do I have a look at that? That might not be the same code. This is a separate file that I'm having sort of used. I built my own. So this is the. So you call obviously you want to.
Okay, so
return
the
float.
15 minutes turned into about half an hour.
Well,
But never mind. Has everyone got on fairly well with that? Hopefully. People who were here last week are struggling to remember Pythagoras' theorem.
I'm struggling to implement it.
And everybody else? Okay, so because we're in a big room this week, we've got a whiteboard and some markers. So would anybody like to volunteer, or I'm going to start picking on people, would anybody like to write on the board how you would declare the constructor for a line that takes 2 points? Yep. Well done.
If I can turn my computer on.
Just put it near the top because we'll write the other ones underneath.
It's
So you're going to have to take a picture of this. Put it on that thing for Tom. Yeah. Semicolons. Yeah. Okay, so that's the struct line, but so we want the declaration of the constructor that takes 2 arguments.
so that's going to be line. It's not very good, is it?
That's all right. That's all right. That's what we do. Right, I am going to have to borrow one of those.
Yeah, sure. There's only a
That's all right. Okay. I'm going to arrange
I
your
see.
hard work for it.
Yeah, no, go for it. Yeah.
Okay. Let's look at the constructor for a line that takes 2 arguments. So first of all, we write the constructor is the same as the name of the class.
Maybe black pen.
Black pen.
Photos. I don't think it will be.
Okay, I'll rewrite these in black pen. Yeah, so. Okay, so we've got our 2 member variables, start and end, and now we're going to add a constructor. So this has the same name as the containing class, struct, and we want it to take 2 arguments, both of type point. So as with all functions in C++, we write the type of the argument first, and then we give it a name. And we want to give them different names from our member variables, because otherwise it gets confusing, right? Because otherwise we'd be hiding some of our variables if we give them the same name. So what we'll do is we'll call it start, and then we'll put an underscore at the end, just to differentiate it so that we know start without an underscore is our member variable, and start with an underscore is the argument that we've just been given.
You say that's a C++ convention, or is it just like your convention? Because I've seen.
It's good practice to give them different names.
Yeah.
What you would usually do, in fact, is do it the other way around. You usually give your member variables
Underscores.
underscores. Often people make them begin with M underscore to say member start. So yes, this is sort of the reverse of what you normally do, actually. Okay, so this is the declaration of I've written it quite small because we're going to add stuff at the back, at the bottom, but if you guys can all see that. So this is a declaration of a constructor that takes two arguments, both type point. Now what I'm going to do is I'm actually going to write the definition of this as well. So we begin with a curly brace. Well, actually, maybe someone can tell me. Perhaps you can tell me how to write the definition of this. What should I put inside this function? Closing curly brace there.
So I guess you need to say start is equal to the argument for start, which is start underscore.
Yeah.
And the same thing with end. So you would say end is equal to end. End is equal to end underscore.
Yep, so I'm going to actually just do it all on one line because we haven't got that much board space. Normally, of course, do this on two separate lines.
So that way you can use that way, so this is done so you can use the arguments later on.
So start and end are the arguments that we've been given. So constructors take arguments just like normal functions take arguments. And in this case, we're saying our member variable start, set it equal to the argument start. Now, later, in fact, very shortly, we'll see there's actually a slightly better way to do it than this. But for now, this is good. So does that make sense to everybody? Everybody got something like this, right? Okay. Maybe somebody can write on the board the default constructor. Who would like to volunteer? Maybe someone from this table. Maybe someone who's looking at me wearing a white top. Come on.
Default, you said?
Default constructor, please. That's
And then we need to actually just draw a curly brace.
yeah. Mine sort of just look like squiggles. But. So you want to set start and end both equal to 0, 0.
Okay. So because these are points here, we can just do start equals. So we want to do it that way? No, we have to do a curly bracket that way to do. Yeah. And I'm trying to do it from memory.
Okay, so the easiest way to do it would be start equals, and then I just write point, so the word point, and then a curly brace, and then 0, 0 in curly braces.
In 0.
I know. Picking on you, sorry.
No, it's okay. I've just never actually written out comments before.
Good interview preparation, this.
Yeah, right. And then, and I'm missing it yet. And then another curly bracket?
Yeah, so curly brace to close the constructor. Yeah.
And that's that. Yeah.
Okay. Two little syntax errors in here. Can anybody tell me what they are?
Did I forget? It's my equals, isn't it?
No, the equals is okay. What I don't like is this comma in the middle. This needs to be a semicolon because these are two separate statements. So normally you'd put them on separate lines. We've squished everything up for the board. But these are two separate statements, two separate things we're doing, two separate sentences, if you like. And that means we also need a semicolon at the end here. But apart from that, that's good. I like that. Okay, so now experiment with using equal. Do you want to just take a photo of this, Tom, before I? Yeah. Okay, so now experiment with using equals default and equals delete. So, if I, sorry Jeremy, delete, if I erase this bit, is everybody fine? Got this? If I erase this bit, so we've just got a line constructor. If I just write equals default in here, did anybody try this? Yeah. What happened?
Got an error.
You got an error.
It's not supposed to be an error? I got an error.
What did it say?
It says, wait, this is the one.
That's surprising because I would expect that to work. So maybe my expectations are wrong. If you've all got errors.
Well, they let me define. They let me define a variable in my main without causing an error. Without just say. So my one it was line.
Sorry, it's a reminder.
Res
Okay.
equals line.
Yeah.
Res equals line.
So
Res colon.
as we said, all this does is calls the default constructor for all of your member variables. And in this case, if you look at the definition of point, we've got the equals 0 in there. So what this will actually do, if you just write equals default, it will do exactly what we want. It will set beginning, it will set start and end 200. So actually, we didn't need to do all that stuff I just made you do on the board. We can just write equals defaults, which is really nice, really handy. We've got a defaulted default constructor. Anybody, I'm not going to erase this bit, but can anybody tell me what happens if I put equals default on the end here? Imagine I did erase that and just put equals default there. Did anybody try that?
That's what I did and I got an error.
Yeah. You remember the error message you got? Okay, the error message will say something along the lines of only default constructors can be defaulted, or I cannot generate a default for this. Because, well, you might say, okay, it's quite obvious. It's quite obvious to me that if I'm taking two arguments and I've got two member variables, I want to assign them. But the compiler doesn't know that. It can't, it's not smart enough to know that you just want to assign start and end to your member variable start and end. So there's no way to generate, to get the compiler to generate a constructor for this. So if you try and default it, it will give you an error saying, I don't know what you mean by a default constructor that takes two arguments. Sorry, by a defaulted constructor that takes two arguments. And then, again, just to complete it, if you write equals delete, what happens for either of your constructors?
It didn't work for me. I don't know if it's supposed to give.
Nothing seemed to happen.
Say equals, so if we replace this default with a equals delete here, what happens?
It gives me an error.
It gives you an error.
Is that wrong?
And what does the error say?
It says something like use, in function void does not.
Error use of deleted function.
Exactly.
Use of deleted function, exactly. That is exactly what it's supposed to do. So if you delete the constructor, if you say, I don't want this constructor to exist, and then you try and use it, it's going to come up with an error saying, you're trying to use a function that we explicitly said we don't want to exist. So that's the whole point of delete, to give you an error message there.
So that people can't initialize anything in the beginning. They cannot add anything to the classes. Like they can't say line, and then put curly braces.
They wouldn't be able to default construct. You'd need to use this constructor. So you need to say, I want you to give me the start and the end. We're not going to assume that it's 0, 0.
just want to report my test case.
Yeah.
So my default is default. This one.
Your default was equals default.
Yeah. And my test case, I said, just give me a line without any argument.
Yeah.
And then I said I want to test that against a line that I deliberately coded to start with 0, 0 and 20.
Yeah.
And I said assert they should be equal.
Yeah.
And it passed.
I find that very strange. Because, did you define an equality operator for your
Yeah, that
line
did.
class?
Oh, I did.
Yeah.
So why is that?
Why did it pass? Because that's exactly what we want. Because this default constructor, what the default does is it just default constructs all of your members. And if you look at the definition of point, it initializes, if we don't give it any arguments, it initializes both x and y, or did I call them x and y? I think I called them x and y, didn't I?
That's right.
It sets both the x and the y coordinates to 0. So in fact, the default constructed point is 0, 0, which is exactly what we wanted. So that's why the test passed. I'm not going to tell you this well. Most of you who tried it have worked out how to do this bottom one. I will tell you it's all to do with Pythagoras, and you can look up the maths, but I'm not going to write the solution on the board, I'm afraid, because something very similar comes up near the end of the class, and I don't want to make things too easy for you. Okay. If we could, you don't think it needs another picture? You're good? Okay. Let's move on. 20 to 8. Let's talk about explicit constructors. So C++, has, we were talking about it earlier actually, has this notion of called an implicit conversion. So, for example, you can convert an int to a double, and a double to an int. One's motion, the other's something else, an arithmetic conversion. We have these ways in which, where you expect one type, you can pass another type, and C++ will convert that for you. And so if you've got a function that takes a double, you can call that function with 3, an integer, and it will convert that int into a double. Or to give you another example, if you have a function that takes as its argument a string, standard string, you can call that function with a string literal. So just some text in double quotes. Now in C++, you'll recall from this, we talked from weeks and weeks ago, that string literals have this funny like native array type. String literals are not standard strings, right? However, if you have a function that takes a standard string argument, you can pass a string literal, and it automatically gets converted. It's implicitly converted into a standard string. So let's give you an example here. In fact, another struct example. I'm really bad at naming things, right? So here we've got struct example, and it's got a constructor that takes one argument. Now in C++, a constructor that takes one argument can provide this implicit conversion for you. So what this means is if we write a function that takes an example, or in this case a const example ref, as an argument, we can pass it an integer. So we can call this function, this function takes an example type as an argument. And we're passing it an integer, which you think would be really weird. But what's happening here is that it's looking at this and going, okay, you want to call function, and you've given me an int. Is there any way at all that I can take this int and massage it into some way somehow I can call func with this thing you've given me. And C++ tries really, like, far too hard, tries really, really hard to match the function you want with the arguments you've given. Right? So what it'll do, it'll take this int, and it'll say, okay, well, I've got this function func, and it takes an example. Can I convert an int into an example? And it looks at the constructor and say, ah, magic. I've got a constructor that takes one argument. It's an int. I've got an int. So I'll just create an example. I'll create an example, and then I'll call this function with that example that I've just pulled out of the air.
But it's a constant, no reference.
Yes. Yeah. So what's actually happening here is creating a temporary, literally what it's called. It's creating this example. Now we've talked about lifetimes and how important that is in C++. It's an example. This example instance springs into life when we enter the function, and it gets destroyed when we leave the function. Because it's a temporary. And in fact, if that only works, I can't really go into too much detail about it now, but it actually only works because this takes a const reference. If it took a non-const reference, that wouldn't work. But anyway, this is a bit surprising, right? We've got a function that takes an example, and we've given it an int, and it works. And that's usually not what you want. Usually these implicit conversions are seen as a bad thing, right? Because you can get into situations where you get implicit conversions where you really don't expect them. They can be very surprising. We don't, in general, like implicit conversions. Fortunately, there's a way to prevent this, and we can use the keyword explicit. And what we do is we put the word explicit before the name of our constructor. So, here we've got example, int I. What we want to do is put the word explicit in there. And when we do that, we're saying we don't want you to use this constructor to form an implicit conversion. And this is such a strong convention that we want to get into the habit of every time we write a constructor that takes one argument, mark it as explicit. So this is one of the many cases, in fact, where C++ got the defaults wrong. Okay, so explicit should be the default, and you should say when, in the rare occasions where you do want it. So, for example, converting a character array, converting a raw string literal into a standard string, that's an example probably of a reasonably good implicit conversion. That's a desirable one.
So you want an implicit keyword and get rid of explicit.
That's exactly what we want, but unfortunately it's probably 30 years too late.
Well, I heard you sit in the powerful committees.
Really not that powerful, and certainly not as powerful as 30 years and billions of lines of code that rely on this working the way it does. This is unfortunately something that's much too late to change the behavior of this now. So we have to get used to it instead, and just get into the habit. Every time you have a single argument constructor, pop the word explicit first.
Sorry, and that's probably why single argument?
Because only single argument constructors are candidates for implicit conversion.
Is that true? How can you? I mean, anything can be implicitly converted. You can convert them, right? I mean, the constructor takes n number of arguments.
Yes.
And that n argument is provided and it match the data type. Why don't, maybe the mistake is only made.
Okay, so let's go back to this one. This is saying, okay, you've given me an int, this definition of func, this declaration of func, sorry, takes an example. How can I convert an int into an example? Now, perhaps what you're thinking is, oh, well, maybe imagine I had a constructor that took 2 arguments, and then you called func34. Fortunately, very, very fortunately, it doesn't try to form a conversion in that case. Only single argument constructors are candidates for an implicit conversion. Fortunately, because otherwise we'd be in an even bigger mess than we already are. Because we don't like implicit conversions. They're sneaky and mysterious and we don't expect them. And we like, in general, like things to be more explicit. As the Python people say, explicit is better than implicit in most cases. So yes, implicit conversions are surprising and bad. And really this is 2 slides worth of just saying, when you write a constructor that takes 1 argument, slap the word explicit in front of it. And so just to reiterate this example, the example, we have this single argument constructor and now we've written explicit there. So we have the same function declaration we did before, but now, when we try to call this, we get a compile error. Now it's saying, now I can't implicitly convert your int into an example. And instead, we have to do it. So this, to anybody who's reading the code, it's far more obvious what's going on in this latter case. Well, okay, it is to me. People seem to be sitting there a bit skeptical.
Because what it was doing in the previous example is implicitly calling an instance, constructing an instance.
Constructing an instance hidden in the background, yes. Exactly.
If you got rid of the example, would it still compile?
What do you mean here?
Yeah.
That's exactly what's happening in this line, right? On the line above.
So if you declare it explicit, you go func example, then just the braces with no example.
There.
So just brace 3 brace.
Use one example, you say.
Brace 3 brace.
That'll be disallowed?
That's a good question. I actually don't know whether that would work or not here. I think Ollie's about to try it.
We're going to try it.
Yeah. I would recommend not doing it. I would recommend doing this. I genuinely don't know what that would do. I suspect it would work, but whether it should or not, I don't know. Oh yeah, just one final thing to say on explicit constructors. In C++, we can give our functions default arguments. So if we...
It does not work.
No? Good. So we've got our function now, void blah, int I, float f. Well, what we can do, what we're allowed to do, is to give this a default argument. So we could say that is equal to 0. And now when we try to call the function blah, we can either give it an int and a float, or we can just give it an int. And if we give it an int, then the float part, the f argument, is given the default value 0.
Just like other languages.
Yeah. Exactly like that. And we have to, if we're going to have lots of default arguments, we have to start from the right. Because we can't We can't have a default value for I and then force people to give a value for f. It doesn't work like that. But we can do this. We can do this for any function, and a constructor is a fairly special kind of function, but it's just a function, and we can have default arguments for functions for constructors as well. And this means that instead of this being a free function called blah, let's now imagine it was a constructor. So now, blah has a constructor that takes an int I and a defaulted float f. Now, unfortunately, it's possible to call this with one argument because we've defaulted this one. So we could say blah brackets 3. So because we can call it with one argument, this is a candidate for implicit conversion. So we want to write explicit in front of this. Even though you're going, well, it takes 2 arguments, it does, but one of them is defaulted. So this is a bit like you've actually defined 2 overloads, which in many ways is a better way to do it rather than using default arguments for several reasons, of which this is one.
You don't need to remove void.
I removed void. Why did I remove void? Someone else.
Constructs don't return.
Yeah, constructors don't have a return value. A constructor, well, I guess you could argue that you could say a constructor returns you a newly constructed thing, but when we write them, we don't write a return value.
But then you don't need to you don't need to do explicit void blah.
No, so constructors you never write it with a return type.
Okay, never.
Never.
You can't return anything.
Yeah. So yes, as I said, it's not always obvious exactly when you can call a constructor with more than one argument. It's perfectly legal to just slap explicit on every single constructor, whether it takes multiple arguments or not. It only really has an effect if the constructor can be called with one. But if you want to be absolutely safe, just stick explicit in front of every constructor you ever write. You can't lose. So that was just a bit of a diversion into explicit constructors. And really, if it all went over your head a bit, don't worry. Really takeaway argument is explicit is important in front of constructors that take one argument.
If you overloaded with just a single int
Yes.
on another arc, and then just didn't have the default in the f.
Yep. And then take that away.
And it's only implicit if you call it one argument.
Yeah. So now rather than having one constructor that has a default argument, now we've got 2 overloaded constructors. Okay? So because this takes 2 arguments, this can never be a candidate for an implicit conversion. So although it's perfectly legal to write the word explicit there, it's useless. It doesn't do anything. It doesn't do any harm, and it doesn't do any good. However, single argument constructor, write explicit. It should be automatic in your brain. Because, like I say, the language got the defaults wrong.
There is a potential use for the explicit, but it's usually not what you want, which is that if you suppress conversion operators. So if you have a constructor that takes a user-defined type, so some structure for it, if you defined in your struct a way to convert it to another type, and then that constructor took that type, by writing explicit on the multi-argument one, you'll break that. They'll have to use static car. It's probably not what we want, but it does have an effect.
Right. I want to keep things simple, but fine. Right, that was just a little diversion to talk about explicit constructors. Let's go on to talk about something that's more useful and something you can have a play with in just a minute. Let's talk about member initializers. A member initializer list. So, I've already said this, the job of a constructor is to set up your class to make it ready for use. To construct the class, it's a constructor. We want to construct the class ready for people to use it. And that means we have to set up our base classes and we have to set up our member variables. Now, the way we did it here was that we had the constructor body and we said, okay, our member variable start, we want to set it equal to this argument that we've been given. But, due to the way the language works, by the time we enter the body, it's already set up our member variable. Am I amusing? Have I said something wrong?
It's fine.
Okay.
No, there's nothing wrong. Nothing wrong.
Okay. Ollie's sitting there, for those who can't see, Ollie's sitting here chuckling to himself, and I've got no idea what's funny, but I'm just going to plough on regardless. Right. By the time we enter the constructor body, it has already initialized start to something. By the time we get to this opening curly brace, start, our member variable, already has a value. It's in fact, at this point, it's initialized it to 0, 0. Because that's the default value for a point. So by the time we get here, start has already been initialized. And now we're overwriting that with a new value. So we're, in effect, initializing our member variable start twice. Now, fortunately, we can avoid this. We can avoid this, so I'm just going to get rid of this. So we can avoid doing this sort of double initialization by using something called a member initializer list. Now, this is something that is special only for constructors. You can't use this in any other kind of functions, it's only for constructors. And what we do is in the definition of our constructor, is we put a colon. It's usual to indent it. But before the opening curly brace, we put a colon. And then we write the name of our member variable. And then we give it the starting value that we want. So 0, 0 there. We probably don't actually want 0, 0. What we're going to do is to initialize it with this start argument that we've got. So this says, before you even get to the constructor body, I want you to initialize our member variable start with a copy of this start. And then we put a comma, and then we'll do the same for end. So now we've initialized our member end with a copy of this end argument we were given.
At the risk of unwittingly stealing thunder, if you declared the 2 points as const, you have to do it. You can't reassign them.
What, up here?
Yeah, if those two are const.
Oh yes, that's a very, yes, we generally want to avoid constant members.
Constructor, I agree. But
So this bit here, between the colon and the end here, this is called the member initializer list. We still need to give this constructor a body. So this is saying, before we start executing the constructor, I want you to set up our member variables. Your member variables always get set up before you enter the body of the constructor. This is saying how you want them to be set up. So we still need to give our constructor a body. So we'll open a brace. Now, what do we have left to do in the body of this constructor? We've set n, we set start to be the same as the argument we've given. We've set end to be the same as the argument we've been given. What do we have left to do? Nothing to do. No, we have nothing whatsoever to do in the body of a constructor. So we can just write an empty pair of braces. A constructor a definition must have a body, but it can be empty. Now doing this, writing the member initializer list and an empty body is incredibly, it happens incredibly often. You see it all and all the time. This is a very, very normal, very usual thing to do. We can still write anything we like in the body. We could print out the value of start and end, let's say. That's perfectly fine. But the point is, by the time we enter here, our member variables, one way or the other, will be set up. The member initializer list is how we control how those get set up. I wrote some slides for this, but I decided that was actually a better way of writing it than I put on the slides.
Is this just because if you don't use this, use the original thing and
Yeah.
initializing the price?
Effectively, yes. What we'd be doing is we'd be setting up start with its default value of 0, 0, and then an end, and then immediately, as soon as we enter the body, then we'd overwrite that.
Okay. So this does not go through that additional step.
Exactly. This doesn't do 2 steps, this just does 1. So as soon as we create start, I want you to initialize start with a copy of the start underscore argument.
Since there's no visible side effects, in practice, the compiler will be able to optimize that out. If we're using a type where it's constructed, it's default constructor did something like print to the console or whatever, then it couldn't elide it. So if something was trivial like int, the compiler's smart enough to figure it out. That's not an argument in favour of not doing this, you absolutely should do this, but compilers these days are quite smart.
So in what occasion that you would think this I would think this is an optimization step.
Yes.
Okay. In what occasion that this optimization would give us huge advantage?
Let me first of all just say it's not just an optimization step, right? One way or the other, your variables must be initialized before you enter the constructor body. So here we've got 2 members that are both points, and points we have seen you can construct a point with no arguments. But what if you had a member that was a type that didn't have a default constructor? In that case, the compiler would have no way of knowing how you wanted to construct your member. It would say, in order to construct this member, I need an argument for the constructor. I need some arguments for the constructor. And the only way to initialize that would be in the member initializer list. You couldn't possibly do it in the function body. And I'm using a member variable as an example. It doesn't often happen for member variables, but this is very common when we go on to talk about base classes, because you initialize base classes in the member initializer list as well, as we'll see probably next week.
It gives me an error when I do that. I need the non-default.
Okay. We'll come back to that. Yeah. Let me just finish this off for a moment.
Sure.
So we've got our struct example. It's got 2 members, mem1, member 1, member 2, m1, mem2. And here we've written a constructor, takes an int and a float, called INF this time. And now we've written a member initializer list. So we're saying member 1, we initialize it with I, and member 2, we initialize it with S. And now in the body of our constructor, our member variables are set up. So I don't know why I commented that out. Imagine it's not commented. You could assert that mem1 is equal to I, because we know by the time we enter the body, the mem1 and mem2 are set up for us. Does that make any sense whatsoever?
It does, but as it's set up, this will only work with a like a parameterized constructor. This isn't a default. Meaning you can't just do example.
Default constructors can have member initializer lists as well.
Okay.
Yes.
And instead of I and F, you would just put something in there.
So you could write example, empty brackets, colon, int, mem1, 0, mem2, 0.0f. Or, if it made sense for whatever you were doing, you could have a default make something completely different. You could have a default, mem1 could be 27 and mem2 could be 5 billion. Yeah, well, it couldn't be 5 billion, but anyway. Here's where it gets, just a tiny bit tricky. If you look at the definition of points, we're allowed to provide a default initializer in the class itself. So the equivalent here, we could, for example, write start 0, 0 in there. This is a relatively new feature in C++. You didn't, once upon a time you couldn't do this. Now you can. That could be 0, 0. We can make it anything we like. We could say 1, 2. In there. And then let's do the same for end. So now the default value we're getting start is 1, 2, and the default value we're getting end is 3, 4. So now if we added our defaulted default constructor back that I removed earlier to make room. If we put this back in, this compiler generated default constructor is going to use these values. Now, why am I saying that? It's because the member initializer list overrides these. Or to put it another way around, if you want to use this value, so let's say end 3, 4 was a good all-round place to end all our lines. We could scrub this out of our member initializer list. And now, by the time we reach the constructor body, start will have that value and end will have the value 3, 4. So the member initializer list overrides any in-class declarations. So this is a sort of very simplified, trivial example, right? You can have dozens of member variables. And you can have lots of constructors. And a way of thinking about it is your in-class initializers, that is these ones, provide your sort of sensible defaults, and then you can have your member initializer list for a particular constructor just overrides those in-class initializers. So yes, the constructor initializer list, the member initializer list overrides any in-class defaults. The key thing,
So could you have, say, maybe start, middle, end?
Yeah.
And then line, point, start, middle, another line, point, middle, end.
Sorry, say that again.
So can you have 2 lines? So you have if your third line down. So if you had if you had point in the points
A point middle.
Point middle.
Yeah.
Say 4, 5.
Yeah.
And underneath you had the line, point start, point end.
Yeah.
And underneath that you had another line, point middle, point.
You mean another constructor?
Another
You
constructor.
can overload
Yeah.
constructors too.
Yeah.
So you could set up all of those.
Yes. Yes,
one after
absolutely.
another, so when that was called, depending on what you.
Depending on what you passed. Exactly that, yes. We can overload constructors to take a different number of different type of arguments. Absolutely. One way or the other, this is, again, something C++, for silly reasons, doesn't always do. One way or the other, make sure all your variables are initialized. Either do it in class, when you define your member variables, or use a member initializer list for your constructor. So I've been nattering for ages. Time for you to do something. So you've hopefully got a class line that's got 2 constructors, a constructor that takes 2 points, and a default constructor. If you haven't, then you've seen how to do it. So what I want you to do is to change those constructors to use a member initializer list instead, which won't be too hard if you look carefully.
If you try to slack him, see what triangle actually used to be.
It's a single colon after so we get the closing brackets at the end of the declaration, a single colon, and then the member initializer list.
Don't have to put it on the line, obviously.
So what sort of stuff would you do in the body?
Well, in this case, nothing.
Yes,
Nothing
but I
to
mean,
do.
what is it actually there for?
Or doing things other than initializing your fields. So maybe you need to do a mathematical operation or print an error, or not necessarily print an error, but print something out. Or maybe you just need to validate that the parameters you were passed were valid. If they weren't, then you throw an exception, and then you prevent the thing from being constructed through an exception.
It's a comma between start and end.
Yes.
This won't let me duplicate all. I'm just trying out what we were discussing because I was writing as you went along.
Okay. So
Duplicate direction constructor.
yeah. So let's have a look what we've got. We've got a constructor. So the top one.
Yeah, which is what you just
Okay.
did
So we've
then.
got it takes.
Start and end.
Okay. So it takes two arguments, both of type points.
Yes.
Okay. And the next one down,
Takes
2 arguments, both of type point.
the different arguments.
It takes 2 arguments, both of type point.
Okay.
So now, if you were to try and construct a line, and you
Yeah,
probably-
you wouldn't know which one to go.
you wouldn't
to.
know exactly.
Yeah.
Yeah. Exactly that.
So you you can't. Okay, so you have to put in even though. Yeah, just can't do that. Even though they're different.
put it in. So I put this in line.hpp. Is that correct? And then I put this. It's not really complaining. No,
Okay, so what's it complaining about?
it's not complaining here.
It's not complaining.
It's complaining here. Sorry. Oh, now it's not complaining.
I think it will complain.
Okay.
If we just play.
Yeah, it's complaining.
Okay, so no matching function call to
Line.
okay, line with empty brackets. Right, so this is telling me you deleted your default constructor somewhere. And if we look in your class, so previously we had a default constructor that was one that took no arguments. So if you put that one back, yeah.
I take this one and put it on the line. See, this is where the line dot this here should go here instead.
No, you need a declaration of your constructor. So if you delete it, so delete them in member initialize, but just go to the end bracket there, the end. So it's highlight all of that and just replace it with a semicolon. Okay. So now we're declaring. This says this type has a constructor that takes 2 points. So now we want to go to line CPP and say, okay, how does this work?
And that's where I use
And
this.
that's where you use the initializer.
So this should start the whole line.
Almost. So if you look at the thing you just deleted, just control X. No. Oh, Z, yes. One more time. That's the one. Okay, so this is the definition of the constructor. And if you look, what we're doing is we're saying we want the function, in this case constructor called line, that belongs to class line. So line approach.
Oh, okay. So it's really just this. Sorry.
It's getting a bit confusing. Okay. Rather than copying and pasting, just try and just don't copy and paste. So you've got this definition of class of your line constructor.
Yeah.
What I want you to do is to change that to use the member initialize list instead.
Because I have to do the initialization as a point and start by now. It's resolve variable start. I can't resolve variable.
So the problem is you've got a semicolon there. What you need is the constructor still needs to have a body. So yeah, and then you don't actually need that semicolon. Now. So we've got a definition of line, the default constructor here. And it works. Yeah, fantastic. And now we're doing things more efficiently. We're using a member initialize list. We're doing things the proper way.
Program.
Yeah, exactly. So yeah, as I say, this pattern of having initializing things in the member initializer list and having the body empty is really, really common. Okay. You're looking worried about things today, Tom. Huh? You're looking very worried about things.
No,
No?
that's my natural.
This is just in actual phase.
Yeah.
Okay.
Because this, I put this in.
Try to look intelligent. It doesn't work always.
No, it doesn't. That's what I thought anyway. It doesn't really. You're supposed to put that outside of the CPU.
sorry, I was watching there, but I got confused here. So I thought this was, you can find this in your struct here.
So if you remember, we can write the definitions of our functions in the class, or we can do them separately. So what we've done so far is I've asked you to do them separately. But you can put the whole definition in the struct if you want. So here, what you've done is put the whole definition in the struct.
Yeah.
Which is fine.
Okay.
There are advantages and disadvantages to doing it, which I haven't really talked about very much, but we will go into it at some point. But
Okay, because I was just looking at this. It's
No,
like everything goes in struct, and then
so if I can, so if you point to the CPP somewhere, you've got
started messing
yeah,
around.
no, that's not messing about at all. That's almost being correct. The only thing is, the member initializer list goes before the body. So you've got that opening brace there.
Okay.
What we need to do is
If you don't put something on, you're not going to be able to see anything.
I'll just put
put it in there. Yeah. So now we have.
Here it is.
So this is saying
right.
definition of this. We have our
But I need
initializer list and then clone.
but I need it in one place.
Yes. So the member initializer list belongs on the definition, not the declaration. So
Yeah.
we can actually just get rid of all of that. Just pop a semicolon. So this is saying there's a declaration. There is a constructor that
Yeah,
takes this,
sure.
and its definition is somewhere.
So that's the declaration for the constructor.
Yeah. And now, what actually happens in the constructor? We don't know. That's
That's what this.
yeah.
Okay.
So whether that uses the initializer list or whether it does it the long-handed way that we saw before, we've got no way of knowing that from the declaration. Right.
Okay.
So we use the member initializer list.
Right.
So the member initializer list goes as part of the definition, not the declaration.
Okay.
I'll probably make that clear enough.
Yeah.
Like you think of it this way, the
Declaration.
Yeah, it's part of the mechanism of the function.
this is generating code. This becomes actual code. So that you have to run, right? The declaration is not ever actually code. It doesn't generate any code. Calling of the declaration is code. The declaration itself is not creating CPU instructions. So because it's something that's creating CPU instructions, it has to be in the definition. Something that's making something the CPU has to run, has to go in the definition.
Right. I think that's what threw me about asking about the body as well, because what was happening was in the HTTP file.
I mean, you can have the definition in the HTTP file, and then the compiler and the link can take care of making sure you don't have duplicates of the code. But generally, you want to separate that.
So HPP is where you put all the classes.
Yeah, well, that's where you declare them generally. So you declare like struct line, and then this would you would just declare the constructors. You have line, point, and then just semicolon ends there. And then in the CPP file, you then fill out these definitions. You have line, colon, line, arguments, initializer list, body. Just like you would for a function declaration, function definition, the same principles apply to structure as well.
Why didn't I do that? Instead of like, I didn't actually do that. I did something else, right? I didn't really do the. I put that part after point. I put that in the CPP file, right? The middle part.
Yes.
And
So you put the declaration in the header.
in the CPP file. I put this whole thing here in the CPP file.
Definition.
The definition. Yeah. Yes.
Fine.
That's correct.
But you're writing struct line, and then you put, so it's like you just do everything under the.
So it's what Ollie's saying. You're allowed to write it all in the header if you want to.
Okay.
And there are advantages and disadvantages to doing that.
But it's cleaner to do CPP.
But yes, usually, most cases, what you want is to have all your declarations just in the header and your definitions in the CPP file. So because I'm just doing this on the board, I just did it all in one. But in real life, you'd pop a semicolon there and not have that bit. Right? So maybe I'll do that. Maybe I'll do that in red.
Practical reason is this: that so you have your header, right?
And you want to use line from 100 different source files. Okay? You have 100 different things the compiler has to compile. Yeah? When it's in the header, if you change this in the header, all of those 100 source files now have to be recompiled because of that change. If, however, in your header you've just declared it, nothing else, and in the CPP file you find it, you get the initializer, you get the body, so you've got to recompile one file. So it will relink if you're only recompiling one file now.
This is about having a constructor defined in the CPP.
Say that again.
So this is about
I'm still
whether
to labour this point a little bit. But I'm not sure how now to use my member initializer when I call my function from my main and use the function. Say if I was using
I don't call the initializer, you just call the constructor. When you create an instance of line, right?
Yeah.
You pass it a point, 2 points, yeah?
Yeah.
This part here and the body as well, they're an implementation detail of this constructor.
Yes. So when I call say a function, say the add function,
Yeah.
I pass 2 arguments.
Yeah.
Those arguments are given start. That's what's assigned to start and end.
No, the operator class is completely separate. That's taking 2 instances of a point, which you've already constructed at some point.
Yeah.
So when you constructed them, you have to do. What you're saying.
So I'm asked, well, I guess where does start underscore and end? Where are the actual values for that cast or store?
They're just their arguments you pass. So I construct a line, so I declare line X, curly braces, and then 2 points. And once you've constructed it, you can pass X to anything.
And they're given stuff. Those are 2 points given start and end.
If you already have an instance and you copy it, that's a different constructor. If you have an existing instance of line, so line X, right? I can then construct line Y from X. It doesn't invoke this. This is for creating one just from 2 points. Completely separate constructor, which is actually generated for you by the compiler.
So for example, I have 2 points. Yeah. But I just need to put in. I've got 2 points. S and T. I've already defined.
Yeah. So you made line D.
And now I'm calling line
That's
D.
calling that constructor there. Yeah.
Yes. So that's going to here.
Yeah.
And it's signing S and.
It's constructing S, which is the line.
Mm.
It's constructing its field, start and end, with the 2 arguments you
Oh,
give.
it's constructing D.
D.
I called it D.
Sorry, yeah, constructing
S
D.
and T.
Constructing D with copies of S and T.
S and T.
They call start and end here because it copies them. Those
Yes,
parameters
because
are copies.
but it's part. But in effect, it's using S and T here
It's using copies.
to make copies.
No, it's using
Using
copies.
copies of S and T to make T.
This is why this is slightly not optimized, because when you call the constructor, because these are by value, start and end are copies of S and T, and then when you do this initializer, it then does another copy, so it will copy construct the fields start and end, the members, with the arguments. So you're doing 2 copies effectively. You first copy start and end, you copy into the parameter list, and then you copy into the fields again.
I'm not using it as
So if you do the const rec instead,
Yeah, exactly. That's what I was.
How are you guys?
Let's have a look.
I just got my
That's
optimization.
actually yeah.
Alright,
Yeah.
excellent.
That's no good. So I don't know.
Because your
Magic.
declaration is
Got it.
as well.
Perfect.
Okay.
Now I have to.
Okay. Before we completely run out of time, let's talk about copy constructors. Here we go. So in here, we're saying in this member initializer, I want you to initialize my member variable start with a copy of this argument I've been given called start underscore. I want you to initialize my member variable start using a copy of this. What does it mean? What does make a copy mean? And the answer is that we can make it mean whatever we want it to mean by defining a special kind of constructor called a copy constructor. When you create a variable, a constructor is used. When you create a class type, a struct type, uses a constructor. When you create an instance, uses it as a copy of another instance, it uses the copy constructor. And we can define our own copy constructors. We can decide how our types are copied, or even whether they should be copyable at all. So the way we write this is we write a constructor, as we write any other constructor, and as the argument type, we write the same type, but as the argument. So we've got line here, so we would write line, open brackets, and then const line reference. I'll just call it other, call it whatever you like. So what this is saying is when we have an already existing instance of line, this one, and we want to construct a new line, use this constructor. So if you think about it for long enough, this is the perfectly logical syntax to use for this. It's saying, I want you to create me a new instance of line using this other instance of line. That is const, that I cannot modify. I cannot modify the other instance because it's const. Because, and again, this is going back way the first couple of weeks where I drummed on about the importance of value semantics. Copies should be independent. So we don't want to modify the thing we're copying from, but we want to use it to create our new instance. We want to make a copy. And in fact, the copy constructor gets used automatically in various places. So when we pass instances, objects, by value to a function, then we're passing a copy. Again, this is something we covered in the first few weeks. The copy constructor automatically gets invoked in that case. And again, when we return by value from a function, conceptually at least, the copy constructor gets involved there. In most cases, actually, that bit gets optimized away. But conceptually at least, the copy constructor is involved. So I've just written it on the board, but I've got another little example here. So now we've got void func, which takes a type example by value. That's important. This isn't a reference, this is by value. Now we've got our struct example, and this is a declaration of a copy constructor. And this actually contradicts something I said earlier. Can you notice what it is?
Explicit.
Explicit, yeah, exactly. So this is in fact, it's a single argument constructor, but it's not explicit. And it's an exception to the rule. Copy constructors, you don't want, because actually you want your copies to sort of happen automatically. You wouldn't want to have to explicitly write the copy when you call this function. So now we create an instance of example, you have to imagine this would have a default constructor as well, otherwise it wouldn't work. And now we're creating a new variable E2 with an automatically deduced type. And we say we want to initialize this from E1. This is going to use the copy constructor to do this. So I'm throwing in auto because we haven't seen it for a while. So I just want you to not forget about it. So it's just a little blast from the past, just to keep it in your brain, right? So this syntax says, I want a copy of whatever E1 is. E1 is of type example. So it says, okay, I'll make a copy. How do I do that? I'll look for the copy constructor.
You don't need any equals.
No, no, this is not an assignment. This is construction. Okay? So assignment happens when we have an already existing variable that we want to modify, that we want to override, that we want to change. This, and I can see it because it looks like an assignment, but in fact this is, we're constructing a new variable. So this is a construction, not an assignment, even though it syntactically looks like an
Well, it
assignment.
has got double equals, has it? Single equals.
So if you had written example E2 and on a separate line E2 equals E1,
That would be an
that would
assignment.
operator equals.
Yes.
Okay.
Yes, absolutely.
So if you have so when it's auto E2 equals E1, that's creating a new E2 from the copy constructor. But if you already created it, like
You already
say
have an example
E2
in
before, it will have called its own constructor then. When you reassign it, it calls the assignment operator. That made sense.
That was absolutely perfect. Perfect.
I didn't get it.
Well, don't worry, because we're going to be talking about the assignment operator probably about 10 o'clock.
Is it just because of the auto keyword, or is it?
No, the auto was just to keep you on your toes, because you probably haven't seen it for a while, just to remind you that it exists. If I wrote the word example in here, then it would be exactly the same. This looks like an assignment, but it is an assignment. It is not an assignment. We're calling it constructor, because we're constructing a new
value.
value.
You never declared it. Because
Exactly.
you never declared E2 before
Well,
you're
yeah.
using it, and so there just has to be a copy. You have already declared it, and then the default constructor would have kicked in, and then you would be using this.
And then we'd be assigning it. Exactly that, yes.
But what's the? I mean, so the purpose of a copy constructor is to copy other constructors so that you can. I mean, what's the use of having a copy constructor?
Copies its functions.
Yes. So a copy constructor defines what happens when the language says, make me a copy of this thing. So just to complete this, for example, when we pass a variable to a function by value, so in this case, we need to invoke the copy constructor, because we're making a new example, a new instance of our type example when we call this function. So in order to construct that, we need a constructor, and it will invoke the copy constructor. Now, we get to customize exactly what it means for copying this type. So for example, if we had to allocate some memory to store whatever the contents of our type might be, then we'd do that in the copy constructor. And then we'd allocate this memory, and then we'd fill it with copies of whatever the contents of our source type would be.
So when you disable the copy constructor,
Yes.
you actually cannot use value ever again on that.
Yeah, you can, but you have to move there. So it's quite complicated, and we will get to it at some point in the course. I haven't wanted to say too much about it, but C++ has this notion of moving things as well as copying. So you can still move into a pass by value.
So if I don't do anything else,
Yes. Yeah, if we just wrote equals delete here,
Mhm.
then this would give you a compile error. It would say, I cannot copy this. I don't know how to copy it because you've deleted the copy constructor. So a copy constructor is another one of the special member functions. It's a special member. What does that mean? What's a special member function?
One of the compiler produces.
Yes. So if you don't write your own copy constructor, the compiler will generate one for you. I've used the weasel word usually because it has to do with these move semantics that I don't want to get into. But unless you do something special, you're going to get a copy constructor.
Well, as long as everything that's a field is also copyable.
Yes. So the compiler generated copy constructor, all it's going to do is copy all of your member variables in turn, which 99% of the time is actually exactly what you want it to do. Now, if it happens that one of your, what Ollie was saying, if one of your member variables is not copyable, because it's got a deleted copy constructor, then you won't get the generated one. Okay, so that's what I meant by usually.
So if your copy constructor equal default,
Yeah,
is equal to if you don't have a copy constructor.
exactly right, yes. So as with the other special members, we can use equals default to explicitly ask for it. And we can also use equals delete to prevent it. Now, deleting the copy constructor is something that you might sometimes want to do. Usually if you've got pointer members that you're responsible for deleting, you don't want, if you were to just blindly copy those, but then in your destructor that we'll talk about, if you were to try and delete that in your destructor, now you've got two pointers pointing to the same thing, they're both trying to delete them. It all gets in a mess. So that would be a very common case for saying equals delete.
Or it's just really expensive to copy.
Yeah. But yes, this is exactly what you said. If we saying equals default, 99% of the time it's exactly the same as not writing anything at all. And I like not writing anything at all, right? That's the easiest code to write. Bug-free, because you didn't write it. Brilliant. This is the important takeaway. Most of the time, you don't need to write your own copy constructor. In fact, if you do things right, you almost never need to write a copy constructor. In modern C++. Back in the C++ 98 days, yes, you had to write all of these things all the time. Nowadays, it's actually quite rare that you need to go out of your way and write a copy constructor, because the default behavior is almost always what you want. However, these things exist, they're important to know about, so I'm telling you about them. Oh, and perhaps I should have put a bullet point on the slides and I didn't. A copy constructor is a constructor, which means it can have a member initializer list. In fact, it usually should have a member initializer list. Yep. And that might be an important little point to bear in mind for this bit. So you've got your line class. I'm now asking you, your line class already has a copy constructor, right? You didn't write it, but it's there. So I want you to write your own copy constructor just for some practice on what it looks like to write a copy constructor.
This would be declared in the CPP file. HTTP file.
Yes, the declaration would go in the CPP, in your HTTP file. Declaration in the header, definition in the CPP file. Even I'm tripping over words.
It's because I'm confusing you on purpose.
Keeping me on my toes.
don't know, since when we started using the whatever PP convention? It used to be just .h. Why is that changed?
It's a matter of style more than anything else.
We just do .h. Does this work?
It works fine. Yeah. I mean, you can
Use anything.
use it. It's not enforced at all. You can use whatever extension you like. A lot of it is. So probably the most common ones for headers are either .h, .hpp, .hxx. I've seen even .H.
Terrible.
Yeah. Personally, and this really is my own personal preference that's leaking into all your examples, but hey, you know, I'm right. So. The .h is also used for C header files. So personally, I like it that if I see .h, I know that's a C header, and if I see .hpp, I know it's a C++ header.
And then it used to be .cc.
Yeah, .cc and .hh, they're pretty common as well. So I used to work on quite a lot of projects that mixed C and C++, so you had to be quite careful about not trying to include a C++ header from your C code because the world would explode. So that's why I like this clear demarcation of this is a C header, this is a C++ header. But it is still relatively common to see .h as a C++ header.
So here, and then the version.
That's perfect, yep. 100%, well done.
Here,
Okay.
and then the
So let's read this. Okay, so we've got class line as a member constructor, line, which takes two arguments, both of type point, and then it uses the member initializer. Okay, so this is not the copy constructor. This is the one we already had that I still want you to have. I don't want you to delete. This is all these exercises are purely additions, right? I'm not asking you to delete anything. What I want you to do.
is to make a new line.
Yeah.
And then here we add this. No,
Oh, almost. So so I want you to write so this is the definition of, so if you look back in line 8 HPP, we've got the declaration of this. Oh, we did have it. We deleted that. Yeah, declaration. Okay. Yeah, so we still want that constructor. What we want to do is to add exactly. Now, if you hover your mouse over it, it would say, declare this, we haven't defined it. So we want to write the matching definition tag. So, see, it's got a hover over it and it's complaining. You haven't implemented it yet, so we want to implement it.
and that's where I do it here.
Yeah.
Do I
So,
do the same? Just do
well, you need, first of all, we need to make the argument list the same. No. We're implementing the copy constructor now.
So just line.
It's const line reference. You can call it whatever you like.
I'm not sure.
Do I also have to do this?
There's no return type on that
No?
constructor.
Yes?
It's
Oh, that's
constructor.
The face is showing no clues.
I thought we wanted to.
I sort of didn't want to say
copy
this was
of
going
the
to be, this was something a bit sneaky, but I thought
Okay,
we're
fair
on
enough.
like exercise 3 now.
So you
I've said,
So you
it's
need
pretty
to do
if you think about it, you still need to do a copy, right? You still need to
getting confused.
do whatever a
confused
copy
with
should
this.
operate. And what the copy should do is it should copy
that's the one.
start and end.
Now on constructor overload.
If we want
you need to do
new
initialize list. You need
value
to
to be
constructor fill out the two.
the same but separate from.
So,
But now we don't have this called start.
Yeah,
and
so
end.
we're on the same line.
So is it like in line? Line dot.
So but what we have is
Initialize
another
the
line,
start.
other,
yeah, and that's
and
going to
other
be
has a
other
member
X.
variable
Oh,
called
yeah.
start.
Other
No, start.
it's not
Start,
dot.
so,
Yeah.
Same for
and then the same with the end.
an empty body.
Yeah.
And then you write the copy.
Yeah.
you need to print out the.
No, you didn't close the parentheses on the start. You opened and you didn't close it. No.
Well,
You closed it too late. Too many idiots.
Oh, sorry.
Just go to your main and
You basically got the end of the start.
reassure you.
You opened the start, you didn't close the start.
Oh, sorry.
There you go.
Sorry.
And then it needs a body. It needs a function body empty.
Yeah.
And then
We're
there
actually
you go.
L3 now.
Oh, sorry. No, this is the body. I was trying to
Oh,
get. I was trying to.
sorry,
I was
I see
trying to.
that.
I was trying to print out.
Yeah, that's fine. That's good.
There's something wrong with this.
You need to evoke the copy constructor,
Which is
Oh, two points. Start is it? Okay.
yeah, you got this.
So that should.
Right. So it's copying L2's constructor.
It's using the copy constructor. So it's copying the values
code
from
opposite.
Yeah. So it's got that's
You've written some code that actually
Yeah.
uses
You
that
can't say
constructor.
it's copying using the constructor from L2. It's using the copy constructor to use the values right to.
magic.
Right,
Got it.
wasn't it?
Yes.
Yeah, that's.
Playing around.
Yeah.
That might take a while to get through. But I'll see what I can do. Okay. All right. So that
He
is
said
the address.
Yeah.
you can't do that by line default, like just like you did before.
I think maybe
And that line is that's the declaration. Then we make the definition of line CPP. So that's
Well, actually, sorry, that would
yeah.
work. Yeah.
This line next one.
It does. It does.
Other lines inside of the line.
So now,
From my context, and then you can just use the so that's fine. And then you print it out over the line. And then in order for you to actually see it, you have to copy one of the other constructors values. So you do const line L3 and then you use L2 or L1, it doesn't matter.
technically,
L
it's
L and then you
constructor
enter that and then
my value
and then you get the answer. That's the answer. You don't use const.
Once you can declare this to
He
me,
said no. He said no.
I overload
Which one?
Well, at least for the
yeah, you
This is the body of the function. Wrap it there as a thing. That was all it was. So it's getting very confused by that. No matching constructor for initialization.
17.
Yeah, but let's have a look. So we've got flip that in close.
Can you get to your
So we've created a const line,
see the bows on there, sorry.
and now we're trying to find a matching constructor. So we've got a const test, and we're looking for a matching constructor.
Interesting.
As we flip to the line class,
Usually you can define any old function like, but we try.
it takes the line class.
Yeah,
That's not a const.
let's try. Like
So it's saying, well, I can't match this because this is not const.
Where's the valid constructor? Yeah.
Do you have these parts?
So
When you're
yes, he asked the same thing. Strictly speaking, no, but it would not be. It would be a bit less useful if you didn't. Because so if you want to copy, if you have a const instance.
you don't need to copy it obviously if you have const, right?
No, so if you have, well, you might want to anyway. So maybe you want to copy it, you want to leave that one alone. There's a second one copy, but the motivation is separate, right? Why you want to do it, yeah, like that. If the copy constructor doesn't take const, then it can only copy things that are not const. Whereas when you have const, say your existing instance is const, it's not mutable. You'd like to take a copy of it.
Yeah.
You need to have a copy constructor accept the
You're
const.
creating a const instance and you want to call a member function on it.
So that's why you want the const.
You have to
Technically,
say,
But then you
I
just
can
like remove both of them and make it not
Let me
const.
show you an example here, right? So we've got some struct
Const
T
is
that does
quite
stuff,
variable.
yeah.
Yeah.
So I've got my first one,
once
yeah.
you
So I'll delete the const, right? So I can obviously do quite legally. I can just do laying that one by the just fine, right? That's
Basically,
no copy constructors B from A, right? Same thing. What will now fail is I can't do this.
So if you write a
Construction
function,
from B.
let's
It's
say
going to fail horribly because B
and
is a const instance of T.
object
This is going to fail.
Make it not a constant, or does it have to be a
right?
constant? Does B
You
have to be a
cannot
constant?
call length.
Well, it doesn't have to be. Maybe you want it to be. Again, this is down to motivation, right? Maybe I just want this to be const because I don't intend. I don't want to modify it. I don't intend to modify it. So it's better if you have no intention of changing an object once you've made it. Always make it const. Then I mean, if I want to take a copy of it because someone else needs to do something, the copy constructor needs to be able to work.
So,
You make your function, you make your copy constructor less useful.
I'm not going to modify this. Right, so we create a const line, then once we've created it, we can never modify it afterwards. Sorry. We can never modify it afterwards. So in the length function, we write that const at the end, and that is a promise that in that length function, we're not going to modify it in any way.
But
Now,
actually,
if you've got a modifiable,
that's an empty promise because I could.
Could you? That's const. It's not a promise. It's a contract.
Oh, because the instance is called.
Yeah. So you could try, but it's going to say, no, you can't do this. It's a const member function. You can't change your members. Sorry, Eric.
No, it's all right.
If you're in construct instance of your struct
I still can't.
const instance of your
We're
struct
not calling
everything
it.
inside it
I
becomes const.
don't know what it's called.
Okay.
Is it?
No,
Do you know what I mean?
yes.
Where's it know then? If I put,
The
I'm putting this
you
here,
still have to declare.
but and it's finding it, it's working.
Yeah.
I don't know how.
Okay, let me read.
It's not a function. You know what I mean?
So that's the rule, is that you copy the structure, you take a constant,
So we have
because obviously the const is
the line.
it will initialize its field just by reading the source, right? You read the source into your destination. So destination is the modify destination.
Yeah.
So now this is exactly what we had before. So we've got create a new line, it's called E1. And say arguments of the constructor and pass
Like use a copy constructor to initialize a new
type
one.
Yeah.
Like
Yeah.
struct.
Okay.
It's const, it's like
And
const. Const
we can actually
const line
try
X,
this.
right, equals A. Const only gets squared
Okay.
by
Yeah.
structure.
Yeah.
Right, so your copy constructor, when your copy constructor is invoked, this is always immutable.
I can also do that. I can write
So it's
Yeah.
only
And I can write
immutable. In your constructing any constructor,
okay.
there's no what constructor you call.
Yeah.
Until you return the same constructor, it's immutable. Once you return it,
So what we have is that when you write something like that, when you construct using the equal syntax, it looks at all your implicit single argument constructors,
Okay.
and it says, can I invoke any of them with this thing on the right? That's what when you construct with this equal syntax, it's looking for the implicit,
Right.
non-explicit single
I have to get my head around. I've just defined it.
Yes.
so
But that's
So
as soon as you put in int
Yeah.
equals int I. It's a type.
Yes.
It's done for everything.
Yeah.
Okay. Right. Yeah.
And
So it's just looking down a list
then
basically.
it's looking at your constructors and say, okay, so we've got one thing on the right here,
Yeah.
and it's a type like line. Do we have any matching constructors? And there is one. Right, it's gone 9, guys. We're going to get kicked out again.
Yeah, I've got a red ring around it, right? Opening parentheses, the const line and then finally that's the end of the bracket, right?
So I guess we'll pick up next week talking about destructors. All right. I'm going to close this down before we get kicked out. So thank you, everybody.
Thank you very much.
Did you have any closing remarks, Tom, before I switch off the stream?
Thank you very much for Tristan for the class, and obviously I encourage everybody to go to pub and pay the respect to the guys.